So far this week, we have discussed infinity, a concept everyone is familiar with, one that likely stretched the limits of your imagination when you first learned about it as a child. Infinity is a fundamental concept leveraged in the very important human history altering mathematics of calculus. As we discussed so far this week, it is quite fascinating to examine outside of our math classrooms. We posited that infinity is a real thing that we encounter in our daily lives. We feel it, we experience it. And if we accept that infinity is a real thing we encounter, then maybe it would behoove us, perhaps, to learn more about it. But what is there to learn? Turns out, a lot. Yesterday, I went over the fact that there are different magnitudes of infinity. Some infinities are larger than other infinities. As crazy as this is to imagine, it was proven to be true. But that is not the only property of infinity that I think is applicable and interesting when it comes to our daily lives. The main thing I want to discuss is what happens when you slice, when you take subsets of infinite things. And in order to properly explore this bizarre behavior, let's first go over some simple, some trivial examples. If you have a regular old finite pizza and you cut it into 8 lovely slices, and then you ate 2 of those slices, 6 lovely slices of pizza would remain. Yeah. Here's one more trivial example. Here, let's think only of the whole counting numbers, the regular ones. 1, 2, 3, 4, and the rest of them. How many numbers are there between 1 and 5? And compare that to how many numbers are there between 1 and 10? The answer is that there are more numbers between 1 and 10 than there are between 1 and 5. Easy. Oh. Okay, enough of that. Let us examine similar questions, but looking at infinite values instead of finite values. Question 1. How many even numbers are there? The answer is an infinite amount. Now, how many odd numbers are there? The answer is an infinite amount. And these two sets of numbers, set of even numbers and set of odd numbers, are equal in their magnitude, meaning that there are an equal amount of even numbers as there are odd numbers. Now, let's combine them. Take the set of all of the even numbers. Combine that with the set of all of the odd numbers. And now let's call what we've created a set of odd and even numbers. So, how many numbers are there in the set of odd and even numbers? The answer, once again, an infinite amount. As we discussed in yesterday's video, though, there are differing magnitudes of infinity. Some infinities can be larger than others. So let's compare the set of just the even numbers to the set we made, the combination, the set of odd and even numbers. Which one do you think is larger? Which set contains more numbers? Do. You may be surprised to find out the answer. These two sets are equal in magnitude, meaning that these two sets contain the same amount of numbers. And this is crazy. Why is it crazy? Because we took an infinitely large thing, added another infinitely large thing to it, and yet our resulting object is the same size. It contains the same amount of numbers as what we started with. It's bizarre. It's troubling, even. But infinite things behave differently than finite things. And when we manipulate them, results are unintuitive. Now, let's revisit one of our trivial examples. How many numbers are there between 1 and 5? And how many numbers are there between 1 and 10? Which set contains more numbers? But this time, let's focus on the real numbers instead of just the natural counting numbers. When I say real numbers, I mean that we are keeping 2, 3, 4, and the rest of the counting numbers you know, but we're also tossing some more in there. Numbers that can be represented as decimals and fractions, like 1.5 and 9 over 10. And we'll also throw some extra funky numbers in there, ones that we can't represent as fractions or decimals, like square root of 2 or pi. So, how many real numbers are there between 1 and 5? And how many real numbers are there between 1 and 10? You guessed it. The answer is that there are the same amount of numbers between 1 and 5 as there are between 1 and 10. The boundary of one set appears clearly larger than the other, yet they contain the same amount within them. Whew. Again, the truth feels weird and uncomfortable. So, in summary, if through some special means you acquired an infinite pizza, you could eat an infinite amount of it and still have an infinite amount of pizza remaining. And if you bought two identical infinite pizzas, you wasted your money because you could have just bought one. And that is going to wrap up our chat for today. Tomorrow we'll go ahead and put a bow on all of this infinity talk, although we could really talk about it forever. Knowing what we know now about infinity, how can we apply this knowledge to the realm of ourselves and our spirituality? That's what we'll talk about tomorrow as we wrap up this week.